Guys, welcome to Chapter 10, The Wonderful World of Circles. We're going to be looking at Section 10.1 today. So, typical with most chapters, the first section of the chapter often deals with a lot of vocabulary and some very basic ideas about the topic. So that's what you're mostly going to see today. We're mostly talking about a lot of the vocab involving circles and just some of the main things that we can identify within the circle. So let me take you up top here for a few vocab words that we're seeing up here. So as you look at the diagram that you see over here, it's a great diagram because it helps identify the three main vocabulary words for our first section here. Okay, so most of these I'm sure you've heard of, but just to be clear, let's identify exactly what these guys are. So if we talk about the radius of the circle, right, a radius. So a radius must go from the center of the circle to one of the edges, right? So like if you looked at FD, that would be a radius. FB would be a radius, and FC would be a radius. So there are three radii in that circle that we can see. Do keep in mind that all radii are equal within a circle. So if you go from the center to any point on the circle, right, that distance is always consistent. So the distance from F to D would have to be the same as the distance from F to C, right? So all radii in a circle are always equal. Let me jump to this one real quick. So the diameter is basically two radii put together, right? So a diameter must go from point to point on the circle, and it must pass through the center of the circle, right? So if you look at DB is the only diameter drawn within that circle, right? Because it goes from one point on the circle to another point on the circle, and it does go through the center of the circle. That's very, very important because we need to recognize that a line like this is not a diameter because it doesn't pass through the center of the circle. We do know that the diameter is, because it's two radii put together, right? FD and FB are both radii. So if we put those guys together, they form the diameter, which means the diameter is always twice the size of the radius. Okay, and so they're giving you some of those relationships right here. There's a few different ways you could write it, but all three of those mean the same thing. So the diameter is, I think this is the easiest one. The diameter is always twice the size of the radius. All right, here's the third one, and this is one you may not be as familiar with. A chord within the circle. So a chord also goes from one point on the circle to another point on the circle, but does not necessarily go through the center of the circle. It can, it just doesn't have to. So EA would be a chord. DB is a chord. So if you look at DB, obviously it's the diameter, but it also fits the description of a chord. So a chord is more of a broader term for any segment that goes from one point on the circle to another point on the circle. It doesn't have to pass through the center. So a diameter is actually a very specific type of a chord, right? So it is still a chord. In fact, the diameter is always the largest chord within the circle because it passes through the center. So if you were ever asked to name DB, it would not be wrong to name it as a chord, but we always want to be as specific as possible, and so it's actually more specific to call it the diameter. So we would want to give it that title. All right, let's go through and identify a couple things. So here's the other thing that you guys are going to see quite a bit of throughout this chapter is this notation right here. Okay, so anytime you want to name a circle, they always name it by whatever the center point is. So in this one, you can see that point O is the center of the circle, so they would name it circle O. Okay, and so that little symbol with the dot in the middle is just the symbol for a circle, and then the letter that follows is going to be the center point of that circle. Okay, so that's why they would call this one center O. We would have called, or circle O, we would have called this one circle F, right? So if we were asked to identify what that circle is, we would call it circle. So we give it the circle symbol, which looks like this, and then we give the letter of the center point. So we would call that circle F. All right. So again, a couple examples for you, and you can just have these for your notes. We're going to do some on our own down here at the bottom, but again, the radii of the circle, they are segments, so we give them a little segment symbol on top. So anything that goes from O to the edge of the circle, so OA, OC, OD, OB, all four of those would be radii of the circle, and do remember that all radii are equal. So all four of those segments are going to be congruent segments. You don't have to start with the center letter. You can flip the order of that. You could have called this OA. It doesn't matter if you say AO or OA. As far as the chords go, remember a chord has to go from one point on the circle to another point on the circle. So if they said, what are all the chords on the circle? Definitely AB is a chord. Yes, we know it's the diameter, but it also fits the description of a chord. So if they did say, name all the chords, we want to make sure we include him. Also CD is a chord. All right, let's go through a couple of our own here for your notes. Guys, it's always a good point for you to pause and try some of these on your own and see if you're getting these right. So if we were to name this circle, again, we can see that R is the center point. So we're going to give it the little circle symbol. So circle. And then we give it the letter for the center point, which is R. So that would be circle R. Name the radii of the circle. So remember, for it to be a radius, it has to connect from the center to a point on the circle. Okay, so we could say RA, RX, RY, and RB. All of those would fit. So let's see. So those would be the 4 radii of the circle. So yes, this is the plural form of the word radius. So if you're only talking about one, then we call it the radius. But if you have more than one, like we do here, then it's radii. Name the chords of the circle. So as far as the chords go, remember it just has to go from one point on the circle to another. So AX would be a chord, AB, YX, and YB. So we should have 4 chords. And again, you can switch the order. So you can call this AX, you could call it XA. Either way is fine, whichever you prefer. So we have AX, we have YB, and then we have the 2 diameters, AB and YX. All right, so name the diameters. Speaking of, remember the diameter must go from one point on the circle to another, but it does have to pass through the center of the circle. Remember, the diameter is always the largest chord within a circle. So let's say AB and YX. Those are 2 diameters. All right, here we go. So little relationship testing. Guys, remember that when it comes to a radius and a diameter, that the diameter is always twice the size of the radius. So if AB, the diameter, was 18, what would that make AR? Right, we know it would be half. So since the radius, it takes 2 radii to equal the diameter. So if the diameter is 18, we know the radius would just have to be half of that, which is 9. Guys, then do keep in mind what that tells you about all radii of that circle. They're all 9, right? So if this were true, then that would make AR 9, that would make XR 9, BR is 9, and YR is 9. All those would have to be 9 under this scenario. All right, here's a new scenario. What if RY was 10? So what if the radius was 10? What would that make AR and AB? Well, let's see. If RY is 10, remember that means that all radii are 10. So we'd be able to say all of this is true. So for this guy, AR, since AR is a radius, it would also be 10. And AB is a diameter, so you can see that would be 10 plus 10. So our diameter would be 20. All right, is AB congruent to XY? So is AB congruent to XY? Well, you can even just see by the numbers that we put up there from the last one that yes, they would have to be congruent. Just like all radii are congruent within a circle, well, so are the diameters, right? You can see just by our previous example that this guy would have to be 20 and this guy would have to be 20 because they both equal 2 radii. So if the radii are equal, then the diameters would also have to be equal. So for that one, let's just say yes. all diameters, I'm going to abbreviate, all diameters in the same circle are equal, congruent. So in the same circle are congruent. All right. Let's look at the back side on this. We're going to deal with one formula today. Probably one you've seen before. This one often comes up as early as pre-algebra. So in this first one, in our formula that we're looking at today, we're learning that the circumference of the circle is pi times the diameter. All right, so look at the circle for a minute. All right, so here's our circle. When we talk about the circumference, what you're talking about is the outside length of this circle, right? It's the distance that you would travel. So let's just say I started right here and I traveled around the circle. So if I started right here and I traveled around the circle, my total distance that I would travel would be the circumference. Now in other shapes, we call it the perimeter. It's the same thing. It's still the perimeter of this circle. It's just with a circle, we tend to give it a special name of the circumference. Okay, but it's still the perimeter of the circle. So you can kind of equate those two things. As far as pi goes, pi is interesting. I know you guys have all heard of it before. We often think of the decimal 3.14 that represents pi, but where did pi come from? If you sort of twist this formula a little bit and divide the diameter over to the other side, you would get a formula that looks like this. So the circumference divided by its diameter is equal to pi. So someone, long time ago, figured out that if you take any circle, no matter how big, no matter how small, but if you take any circle and you divide the circumference of that circle by its own diameter, you get the same value every single time. 3.14, on and on and on and on and on. So they gave it a special title, right? They gave it this Greek letter pi. So that Greek letter for pi represents the relationship between a circle's circumference divided by its diameter. So that would be true for any size circle. You take any circle, if you were to figure out its circumference, so if you measured the outer length and you divided that outer length by its own diameter, you're going to get 3.14 every single time. All right, so that's where pi came from. So what they did with this formula is we now use it to figure out the circumference, right? Because pi is consistent. It's always 3.14 approximately. And so if we take that d and multiply it back over to here, we get this formula. And so now they'll say, well, how do we figure out a circle circumference? Well, we take its diameter, multiply it by pi, and we get the circumference. There is a little variation to that formula. Remember, we know that the diameter is twice the radius. So the other way that you can write this is instead of d, you can put 2r, twice the radius. Same formula, just written in terms of the radius rather in terms of its diameter. Okay, but otherwise it's the same formula. So typically what people do is if they know the radius, like this one, then they tend to use the formula this way. But if you were given the diameter, if I were to have told you that the diameter is 26, they would have just plugged it directly into this formula right here. So we can kind of use it either way, whichever, depending on which information you're given. So real simple formula, if we take the radius, which is 13, and plug it in for r, so we have twice the radius, which is 26, times pi, gives you this. Guys, I want to make something really clear on this, so please hear me. There will be many times where you're going to be asked to leave your answer in terms of pi. If you look at these two solutions right here, both of these are accepted ways of writing an answer for a circumference. One of them is exact. When you write 26 pi, that is an exact value. Okay, everyone knows what 26 pi would represent, right, in terms of writing the circumference that way. So if you are ever asked to write your answer in terms of pi, stop here. This is the way we want to leave that answer. If they say round it to the nearest hundredth or tenth or whatever they say, then plug it into your calculator and you can round it off. So you should have a pi button in there. Guys, don't use 3.14. Use pi. It's more exact. Okay, so we always want to use the pi button. So we would actually type it in to look like this. And type it in as 26 pi, hit enter, and then you can round it to the nearest hundredth. Okay, so 81.68. All right, let's try a couple. So find the diameter and the radius. So now on these ones, we're actually going the other direction with it. Okay, so now they're telling us what the circumference is, and they want us to use that to figure out the diameter and the radius. So not a whole lot different here. Remember, this is our formula. That the circumference equals pi times the diameter. Well, they're telling us in this case that the circumference is 40. So if C is 40, then I'm going to take my 40 and sub it in for C. And we're going to use that to figure out what our diameter is. So what do you guys think? How would I get D by itself? How would I solve for D in this case? Well, remember, this is just basic algebra, right? This is pi times the diameter. So if we divide both sides by pi, that would put the diameter by itself, and now we could punch that into a calculator and get that answer. But again, guys, I do want you to remember, if you're ever given directions that say leave your answer in terms of pi, stop here. That would be your answer. But this one does specifically say round it to the nearest hundredth. So we would go in, type in 40 divided by pi, and to the nearest hundredth, we would say 12.73. The other thing they asked us to find on this was the radius. Well, if my diameter is this, how do we use that to figure out the radius? Remember that relationship? It's half. So we know that it takes 2 of these to get the diameter. So if I take my diameter and divide it by 2, now I have the radius. So if we round that to the nearest hundredth, 6.37. All right, so if you want to kind of pause here, you could try this one on your own. It's going to be real similar to what we just did. I'm going to take that same formula. I'm going to replace my circumference with 256. So a little substitution into our formula. Again, we're going to divide pi to both sides. So if they were to ever ask us to leave our answer in terms of pi, we would stop right there. This one says nearest hundredth, so let's type that in. So 256 divided by pi, 81.49. Make sure you round accurately. So that's the way that we would write it. As far as the radius goes, we know that if we divide the diameter by 2, then I get the radius, so 40.74. Guys, what if they said, find the radius in terms of pi? Well, you'd still go from here, right? I would just simply take 256, divide it by 2, and it becomes 128. So if I were to write this as 128 over pi, that would be my radius, right? But this one, again, did specifically say nearest hundredth, so we're just following those directions. I just want you to keep in mind when they say write your answer in terms of pi, what that would look like, because we are going to run into those. Okay, so let's expand on this idea, and we're going to end on these 4 examples here. So what is the exact, oh, here we go, exact circumference of each circle using the given inscribed or circumscribed polygon? So if you look at this circle, anytime you put a shape inside of it, we call that inscribing the circle. So we would describe this as, this is a triangle that has been inscribed inside of the circle because it's on the inside. And you'll notice the vertices of that triangle are on the circle. Right? So the 3 vertices have to be on the circle in order for it to be inscribed. So what do they want us to find here? They want us to find the circumference. Well, in order to find the circumference, we know that we need the diameter. So we need to be able to look at their information that they gave us and use it to figure out the diameter of that circle. Well, what do you notice about that triangle? It is obviously a right triangle. So we just learned in a previous chapter how to find this guy within a right triangle, right? So remember a good old Pythagorean theorem here. So if you did a little 8 squared plus 6 squared equals, so you could call this c squared. You know, I would probably avoid using c because it also represents a circumference. I don't know if that would get confusing for you or not. I'm just going to call it the hypotenuse squared. Or you could call it the diameter squared. Let's call it the diameter squared because that's actually what we're trying to find right now. So if you solve that for Pythagorean theorem, we're going to get that the diameter is 10. And for any of you who learned any of your Pythagorean triples, you might remember that the 3, 4, 5 numbers, if you double them, you get 6, 8, 10. Right? So that's kind of a nice little shortcut. But anyway, now that we know that the diameter is 10, I can sub that in for D. So guys, you'll notice on this one, they said find the exact circumference, which means stop there, right? That is exact. Nothing has been rounded yet. If I try to put that into a calculator, oops. So if I type in 10 pi, I can't write this as my answer because it would be rounded. It would no longer be exact. Guys, even if you write every number on the screen, it's still a rounded number, right? Those numbers go on forever, right? This is just as much as my calculator is able to show us, but it's still not exact. So when they say exact, that means leave it in terms of pi. All right, let's try it on this one. So here's a very similar one if you want to give this one a shot. Guys, you'll notice on this one that this is 9, and based on that mark, this one is also 9. So what kind of a right triangle must this be if my two legs are equal? That must mean it's a 45, 45, 90 triangle, right? So the two legs are 9. What would that make the hypotenuse? Well, we learned in our previous chapter that if you take the leg and multiply it by the square root of 2, you get the hypotenuse, which in this case is our diameter. So, guys, keep in mind for this one, you could have used Pythagorean theorem. You could have said 9 squared plus 9 squared equals d squared, and you could still come up with a radical like this, right? But there's a great shortcut in recognizing the 45, 45, 90 patterns. So again, let's go back to our circumference formula. I now know that my diameter is 9 root 2. But guys, again, super important on this that they did give us the directions to give an exact circumference. Neither one of those could be put into a calculator and you'd come away with an exact number. You would have to round it, which means if you see something like this, it means leave radicals as radicals and leave pi as pi. Okay, so we want to stop there. Any of that into a calculator would come away with an approximate answer. It'd no longer be exact. All right, what about this? We now have a rectangle inscribed within this circle. Guys, again, notice that all 4 vertices of that rectangle are actually on the circle. That's what makes it inscribed. As I look at this, well, think about just a basic property of a rectangle for a minute. If this length is 7, what would that make this length? Wouldn't it also have to be 7? Right? Just like if the right side is 3, the left side is also 3. So we certainly can see that. Well, guys, within this, again, I'm seeing this right triangle. So if you sort of ignore half of that rectangle, so look at it this way, notice we're looking at a right triangle where the hypotenuse is the diameter. So again, let's go back to doing what we did right here. We're going to say that a squared plus b squared equals c squared. Again, I'm going to use d for the diameter, just so I don't confuse my c's with a circumference. Let's clean this one up here. 9 plus 21, 49, equals d squared. So if we simplify, puts me right here. So if I square root both sides, square root of 58 is my diameter. Guys, in this case, again, you cannot put that into a calculator and get an exact answer. It's going to be rounded. So if they say give an exact answer, then just leave your radicals as radicals. If you could simplify that radical, do it. But the square root of 58 cannot be simplified. That is as simple as it gets. So in this case, let's go back to our formula. I can now replace my diameter with the square root of 58. And that's it. So that would be an exact answer. Of course, if the directions said round it to something, then we would type that into a calculator and round it. All right, here's the last one. Guys, so far the three that you've seen had polygons, shapes, that were inscribed within the circle. This one's a little different because this one has a square, a polygon, on the outside of the circle. So we call this one a square that is circumscribed about the circle. So if it's on the outside of the circle, then it's circumscribed. Inside is inscribed. So if we look at this one, what do we know about this? This one is often one that tricks people because they look at that circle and they say, man, we don't know anything about it. We don't know the radius, we don't know the diameter, we don't know circumference, we don't know anything. Well, keep something in mind for a minute. I'm looking at a square here, right? Could I redraw that line somewhere else? Why not draw it right here? Wouldn't that be the same length? So from top to bottom is 11. That's what they're trying to tell us. So what if we drew that same 11 from top to bottom right there? Wouldn't that be the same length as what they're showing us? Of course, right? So obviously that 11 would be the diameter. So in this case, again, here is our formula. We can now replace our diameter with 11. And because this one specifically said an exact answer, we're going to stop there. All right, guys, that is it for 10.1.